Hello and welcome back to the classes by Mrs. Monisha. We are back today with a new topic, squares and square roots. What do you mean by square of a number? Suppose I write a number 4 and square means when I multiply the number 2 times. That is, if I multiply the same number to itself twice. So the answer here becomes 16. So a number that is multiplied to itself 2 times is represented in the form of x to the power of 2. We have already learned about the topic exponents. If you have any queries about how what is power and what is exponents, then you can please go back to the videos based on the topic exponents, the links of which will be mentioned in the description box. So when a number is multiplied twice to itself, then we say the number is it's squared. Okay, so suppose I say 7 square, it means 7 into 7 and its value is 49. Say for an example 2 by 3. So the square of 2 by 3 would be 2 by 3 into 2 by 3, which is 4 by 9. So the square of 2 by 3 is 4 by 9. Square of 7 is 49. Square of x is x square. Square of 4 is 16. So this is squaring of a number. Now the numbers perfect square. There are some numbers called perfect square, or we can say square numbers. Now what are these? Perfect squares or square numbers. Now we know what a natural number starting from 1. So if I take the square of the first natural number, that is 1 square, its value is 1. The next natural number is 2 square, that is 4. Third natural number is 3 square, that is 9. So if you keep taking the squares of the natural numbers, so the numbers that you obtain here, they are the square numbers. That is 1, 4, 9, 16, 25, 36, 49 and so on. Okay, so what are square numbers or perfect squares? These are natural numbers which are squares of another natural number. So we can represent perfect squares in this form. Say a natural number x which can be expressed in the form of n square. Say where x and n both belong to natural numbers. That is, both belong to the set of natural numbers. So x is a natural number which can be expressed as the square of another natural number. Okay, so from here you can see that all the perfect squares are also natural numbers. But remember, not all natural numbers are perfect squares. Say for an example 10. 10 is a natural number, but 10 is not a perfect square. So all perfect squares are natural numbers, but not all natural numbers are perfect squares or square numbers. Alright? Okay. So square numbers, I repeat once again, what are square numbers and square of a number? To find the square of a number, it can be any number. It can be a fraction, it can be a natural number, it can be a decimal. So square of a number means when you are finding the square of a particular number. This number can be belonging to any category any category including your natural numbers. But when we say the perfect squares or square numbers, we are always trying to find out the number which is the square of a natural number. So perfect squares are always natural numbers, but square of a number may not be always a natural number. Say for an example, 2 by 3 is 4 by 9. So 4 by 9 is not a natural number, but it is square of a number. But if I say 2 square, which is 4, so 4 is a natural number. So here this number is a perfect square or a square number. So perfect square always has to be a natural number, whereas square of a number need not be a natural number only. Alright. Now, how do we determine whether a given perfect square or a given natural number is a perfect square or not? Say for an example, let me give you a number 324. I have randomly given you a number. Now, how do you decide whether this number is a perfect square or not? That is, whether this number can be expressed in the form of a square of a natural number. How do we decide? So for this, you will be using your prime factorization method. So if you use your prime factorization method, so you see this 324, we could express this in the form of 2 into 2, 3 into 3, 3 into 3. So see, we are making pairs. What pairs? Pairs of equal prime factors. So this number 324, it could be expressed in the form of product of pairs of equal prime factors. Equal prime factors made into a pair, equal prime factors made into a pair, equal prime factors made into a pair, and product of them has been done. So if any number is expressed in the form of product of pairs of equal prime factors, that is, everywhere you will get a pair, no number is left unpaired, then in such a case the number will be a perfect square. So this one is 2 square, 3 square, and 3 square. So see, each of these prime factors could be written in the form of a perfect in the form of pair. So this number is actually, so now we have learned laws of exponents, which says a to the power n into b to the power n is equal to ab whole to the power n. If you are not comfortable with the laws of exponents, please go back to the videos based on laws of exponents. The chapter has been done over there. Okay, so this, so we can write, since all of these three numbers, they have bases having the same power, so we can write 2 into 3 into 3 whole to the power 2. So this is 18 square. So this 324 is 18 square. So see how easily we could express it into the form of 18 square. That is, we could find the value of x. X is equal to 18. That is, 324 is a square of 18. So let's take another example. Let's take 6400. So we'll first find the prime factorization. Okay, so 624 could be 6400 could be expressed as, so you see, 2 square into 2 square into 2 square into 2 square into 5 square. So we could express each of these as product of pairs of equal prime factors. Each power 2 means it's a pair. 2 into 2, it's a pair. 2 into 2, 2 into 2, 2 into 2, 5 into 5. So now if we put them together in according to the laws of indices, that means 16 into 5 is 80. 80 square. That means 6400 equal to 80 square. You can cross check if you want. 80 into 80. Yes, 6400. So this is the way you can decide upon whether a given number that has been given to you is a perfect square or not. That is, if you are able to express the given number in the form of product of pairs of equal prime factors. All right, and also you can find out the number whose square is the given number. Okay. Now let us do one sum, that is how to find whether 7056 is a perfect square or not. I'll give you 10 seconds. Quickly find a number whose square is 7056. Find the number whose square is 7056 if 7056 is a perfect square. So first you will determine whether it's a perfect square or not. If it's a perfect square, then find out which number's square is this number. Quickly, come on. Most of you might have done already. Let's check whether you have done it correctly or not. Okay, so we can see we could express it in the form of pairs. That means 2 square, 2 square, 3 square, 7 square. So see, all the prime factors are in the form of pairs because power 2. That means this is 4 was the 12, 12 was 84. 84 square. So 7056 is 84 square. Alright. So this is the way you can find out whether a given number is a perfect square or not. And if it's a perfect square, you can find out which number is the what is the number whose square is this given number. Alright. Now, for an example, if you have a sum like this, find the square. Find the number whose square root is. Say let's take an example. 1086 by 121. So you can see that this is a mixed number. So remember, if you have to find out whether a given number is a square of a suppose a fraction is a square of another fraction or not. So how do we do it? If you can express this fraction in the form of product of prime factors of this fraction of this the numerator, as well as you can express the denominator also in the form of product of pairs of equal prime factors. If you can express each of them, the numerator and the denominator in that form, then you can easily find out the fraction whose square is the given fraction. Say for an example, this sum. So if you convert this mixed number into a improper number, you will get 1296 by 121. So if you find the prime factorization of 1296, this is 6, 4, 8, 3, 24, 162, okay, so this is 2 square, 2 square, 3 square, 3 square by, now 121 is 11 into 11, that is 11 square. So this one is 2 into 2 into 3 into 3 whole square by 11 square. That means 2 is a 4, 4 is a 12, 12 is a 36. So 36 by 11, 36 square by 11 square. So we know already a square, a to the power n by b to the power n is equal to a by b whole to the power n. If the numerator and the denominator have the same powers, then we can write them together as 36 by 11 whole square. That means this number is nothing but the square of this fraction, that is 36 by 11. So 1086 by 21 is the square of 36 by 11. Alright, fine. Now, a little question. Say, find the smallest number. Find the smallest number by which 9408 should be divided so that the quotient is a perfect square. Also find the square root. Now what is square root? Now as and when we do the sum, I will discuss what is square root. Square root of the quotient. As we come to this part, I will discuss this one. So first is find the smallest number by which this should be divided. That means this number is not a perfect square. Okay. This has to be divided by some number so that the quotient becomes a perfect square. Then let us still check whether this number is a perfect square or not. So this divided by 2, that is your 4704 2 3 5 2 1 1 7 6 5 88 294 147 3 49 77 7. So you can see 9408, it could be expressed as, so 2 squared 2 squared 2 squared 7 squared and 3. So see, each of them are in pairs, only this 3 is left unpaired. Okay, 2 squared 2 squared 2 squared and 7 squared, these were in pairs, only the 3 was left unpaired. So if we remove this 3, then we get the rest of them all in pairs. That means the number can be changed to a perfect square if we remove this 3 from here. So now if we have to remove this 3 via division, because the question is by which it should be divided. So if you have to remove it via division, then you have to divide this by 3. Then this case, this side also gets divided by 3. So 3 and 3 gets cancelled. So we get over here, that is your 3 1 3 6. 9408 divided by 3 is 3136, and this is 2 square into 2 square into 2 square into 7 square. So we can write this in the form of pairs of product of pairs of equal prime factors. That means this is 2 into 2 into 2 into 7 whole square. That is 4 to the 4, 4 to the 8, 8 into 7 is 56. So this is 56 square. So 3136 is 56 square. Now this word, that is square root, this is nothing but finding the opposite of square. Means when you square a particular number, when we find x is squared, suppose we get y. Okay. Now when you do square root of y, you get x. Like if we have learned addition and subtraction, they are inverse operations. Multiplication and division, they are inverse operations. Similarly, square and square root are also inverse of each other. So if you square a number, you get this y, and if you square root y, you will get x. So when you square a number, you get a number. Now square root of a number is finding the number which was obtained by doing the square of this number. Okay. So like for an example, 2 square is 4 and square root of 4 is equal to 2. Alright. Square root of 4 is equal to 2. So this 56 square is 3136 and 3136. This is the sign of square root. This square root of 3136 is 56. Alright. So that was our question. Find out the square root of the quotient. So because once we divided this by this, our new quotient was 3136. So when we had to find out the square root of this, so we already have the prime factorization done in the previous step. We need not do the prime factorization once again. Okay. So we already have this done. So just remove the 3 from there. So we have this as 56 square. So the square root of 3136 is your 56. Alright. I hope this is clear. Now if the question would have changed from being multiplied or from being divided to multiplied, then what would have you done? What would have been the change in this question? The change would have been here, that is the change would have been here 3 was unpaired. Okay, the 3 was unpaired. So by what number you should multiply so that the instead of quotient would be the product is a perfect square. If they change the question in this way, and also find the square root of the product. If I change the question to this format, Then you see how the question changes. The solution changes simultaneously. 9408 was expressed in the form of 2 square, 2 square, 2 square, 7 square into 3. Now we can see that 3 is left unpaired. So you have to multiply it with some number to make it a perfect square. So if I multiply it with 3, then this side also has to be multiplied with 3. So now you see 3 is having a pair now. Okay, initially 3 was unpaired, so if I multiply, you have to check. See, the logic is very clear. If you have to divide something, that means the unpaired number has to be removed. So the given number is to be divided by the unpaired number. And if you have to multiply it with something so that the given number becomes a perfect square, then you have to multiply it with the unpaired number. Previous case, the question was division, so we divided with the unpaired number. In this case, I've changed the question to multiply. So multiply with the unpaired number. So another number you are bringing into the scenario. So this becomes 2 square into 2 square into 2 square into 7 square into 3 square. So in the previous case, the unpaired number is removed, and in the new case, another number is another number is bought, so that the unpaired number gets a pair. So here also you will be doing the multiplication. 2, 8, 2 to 4. Just a calculation, 1 second. 2, 4, 12, 20. Yes, the new number, the new product is this, and it is actually 2, 2, 2 whole square. That is equal to 4, 8 divided to 8 is 68. This is 168 square. Okay, so that means square root of 28224 is equal to 168. Okay, because once you do 168 square, you will get 28224. So square root of 28224 will be 168. Okay, fine. So I hope this is clear. Now if the question had none of these stuffs and the question was just find out the square root. If the question is just find out the square root, say 3136 is given to you and you are asked just to find out the square root of this number. Just find out the square root. So what will you do? First find out the prime factorization. So in the previous sum only we had done the prime factorization of 3136, which was 2 square, 2 square, 2 square and 7 square. The prime factorization of 3136 is 2 square, 2 square, 2 square and 7 square. Now when you write the square root of this 3136, then you just write the square root of this. Square root of this means square root of this. Now for each prime factor you will make the power half and bring the prime factor out of the root sign. So here 2 was having a power 2. So break that and bring it down. 2. 2 is made into half. This 2. The power has to be halved. These powers have to be halved. So 2 to the power 1, 2 to the power 1, 2 to the power 1, 7 to the power 1. So 2 to the 4, 4 to the 8, 8 to 7 is 56. This is one way you can do, or the other way you can do, since I have taught you already that when the bases are same, the powers can be added. Laws of exponents. So this is 2 to the power 6 into 7 square. The alternate way of doing it is, so for square root of 3136 is 2 to the power 6 into 7 to the power of 2. As I said, the power has to be halved. So when 2 is brought out of the root sign, 2 will come with a power half. That is, power is 3 and 7 to the power of 1. So 2 cube is 8. 8 into 7 is 56. Now some of the students might have a question, ma'am, why is the power made half? Correct, no problem. See, if I find the square root of 2 to the power 6 for an example. Square root means, square means to make a square of something means you are raising something to the power of 2. So suppose x square is y. Now when I write square root of y, what does it mean? What is the numerical form of this square root sign? It means y raised to the power half. Okay, here it was raised to the power of 2. I told you square and square roots are inverse operations of each other. So if squaring something is raising it to the power of 2, then square root means raising it to the power of half. So here it means 2 to the power 6 whole to the power half. The square root means what? 2 to the power 6 is raised to the power half. And we have already learnt in laws of exponents, a to the power m whole to the power n is a to the power m into n. That means these two have to be multiplied. So 2 to the power 6 into half. That is 2 to the power of 3. That means, as I told you, make it half and bring it down 2 to the power of 3. Why I said half? Because here this half is multiplied because why is the power half? Because of this square root. Square root has the value half. So the power 6 is multiplied with this half, and thus the power is becoming half. Alright, so I hope this is clear how to find the square roots and squares of numbers. Most of the cases you can see you are using laws of exponents over here. If you're not very much clear with the laws of exponents, I would request you to go through the videos that have been uploaded for the topic exponents, so that you're clear with that. Once you covered that, then this becomes much more easier and you'll go faster with this topic. So I'll be coming up with a new part of this chapter, that is finding out square roots using division method. This what we have done is finding square roots using prime factorization method. Next we'll be coming up with the faster method, that is finding square roots using division method. So till then I hope you will go through this video and make your concepts clear here in this part, so that the next part becomes easier to you. See you very soon in the next video. Till then, bye. Welcome back to the classes by Mrs. Monisha Natwal. We are back again with the continuation lesson square and square roots. Today we are going to learn to find the square root of a number using the division method. In the previous video we have already learnt about how to find the square root using prime factorization method. If you have not gone through the video, please go through, so that both the methods are very well known to you and you find it easier to find the square roots using any one of the methods. So we'll start with the division method here. So using division method, we are going to find the square root of 729. So the method is very simple. If you understand the method logically and systematically, then for any given number which is a perfect square, you can find out its square root. Say 729. First you will put the division symbol and then start pairing the numbers. You will start pairing numbers. How do you pair numbers? From the right hand side, that is from the units place, you will start pairing the number. That is units and tens become one pair. Next we have 7. 7 is a number without any pair. So you can keep a bar over the 7. So for each pair you have to place a bar. Okay, but 7 is a single digit. It has no other pair or no other digit to be paired with. So you can keep 7 as a pair. So each pair of digits and the remaining digit that has been there in this case we have one digit in the first place. So these are called the periods. Each of them are periods. Okay. Now how to go ahead with the division? Now your first number that you will start working it is with 7. So you can think 7. Now tell me a perfect square which is either equal to 7 or less than 7. So in the series of perfect squares, it is 1, 4, 9, 16 and so on. So which number is a perfect square which is lesser than 7 or equal to 7? Equal to 7 it is not possible. We can see there is no number which is a perfect square and equal to 7. But we can see 4 is a perfect number which is perfect square which is less than 7. So how do we obtain the 4? 2 2s are 7. So above each pair you will write its quotient. So 2 2s are 4, not 7, 4. Now take the subtraction, see 3. Now you will bring down the quotient. Bring down the remaining dividend over here. So this is the new dividend, 329. Alright. Now what is the quotient here? 2. Now double that. Double of 2 is 4. Keep some space over here and then double the digit and place it over here. Now what do we place over here? Now You have to think of a digit which will be placed here as well as the same digit will be placed here, so that when we find the product of this into this, we get a number which is either closer to this or this. I repeat, once you double this quotient, place it here with some space, because this space is kept for entering a digit over here. Now whatever digit you enter over here, with the same digit you will be entering over here in the new quotients place. In the second period, for the second period, the same digit has to be entered here, so that when you find the product of this as a number into this is the new divisor, this new divisor into this quotient here will either give you this result or a number lesser than that. So what should we place over here? So 40, tell me what you should place over here. 47 if I place over there into 7. How do I decide whether I will place 47 or 42 or what? You see, whatever number is to be placed over here, the same number will go over here. So the units place here when multiplied this should be giving me a 9 over here. So what numbers when multiplied give 9? Either you will get 3 into 3 9 or 7 into 7 will give you a 49. So the 9 in the units place. So either 3s or 9s when they are squared, they will give you 9s in the units place. So 7 into 7, 9, 32. So here we will put 7. Here also 7. So 47 into 7 is 329. So the remainder is 0. So once the remainder is 0, that means you have got the square root. That is, when the periods are all exhausted, that means you have found out the square root. So the square root of 729 is equal to 27. Alright, I repeat once again. Whatever number has been given to you, put that within the division symbol, and then you start pairing the digits from the right. So the units and the tens is one pair. Next goes the hundreds and the thousands and so on. So if you have a single digit over here which is having no pair, then you put that as a single digit, and each of these pairs along with the single digit, if there is any, then these will form different periods. Okay, so from here only you can get one concept, that how many digits can your given number have in the square root. So if the number of digits in the square is n, say n is even, so for each for n digits, how many pairs are we going to get? N by 2 pairs. Okay, suppose there are 4 numbers. 4 numbered means when you are pairing them, you will get 2 pairs. So for each, that's why I told you above each pair write its quotient. So for each pair you are getting one digit of the quotient, that is 1 digit of the square root you are getting. The number here is the square root. So for each pair you are having 1 digit of the square root. So that means if your n is even, that means you have n by 2 pairs over there. That means these many digits you have in the square root. Alright. And if your n is odd, like in this case, so 1, 2, 3, there are 3 digits, n is odd. So n plus 1 by 2. Why did we do n plus 1? Because this single digit will also work as a pair. I mean, you are considering it also as a period. Each period is made up of 2 digits, giving you 2 digits each period. So, but here, because the last digit here while pairing, we saw that this is the last digit which is having no pair. So the single digit was treated as a period. So that means how many periods you are getting. So actually you are counting how many periods rather than pairs. So here single digit also is forming a pair, forming a period. So for 3 digits, so what would be, suppose 3, so 3 plus 1 by 2, that is 4 by 2, that is 2. So see, 2 digits we got over here. So for odd, you will get n plus 1 by 2. So suppose if your number of digits in the square is 5, so your square root will have n plus 1 by 2, that is 5 plus 1 by 2, that is 3. 3 digits in the square root. If it is having 8 digits in the square, then the square root will have 4 digits, because 8 digits will give you 4 periods. So for each period, you will have 1 digit in the square root. That means there are 4 digits in the square root. And suppose you have 9 over here. in this, suppose 9 or let's say 7. If you have 7, then 7 digits will also give you how many periods? It will give you 4 periods, because the first digit from this side, from the left side the first digit, also from the right side when you are pairing the last digit here, this will have a single digit, but still it will form a period. So that's why for each period, so how many periods you are having over there? So 7 plus 1 by 2. So 8 by 2, that is 4. That means your 8 digits will also give you 4 digits in the square root, and a number with 7 digits in the square will also give you 4 digits in its square root. So counting the number of digits is quite clear, I suppose. Okay. So repeating this again. So suppose 7. Once we made the periods, we saw that 7 was the single digit over here. So you have to find a perfect square which is either lesser than this or equal to this. So since 7 is not a perfect square, so a perfect square that is less than 7 is 4. So how do we obtain 4? 2 square. So 2 2s are 4. Alright. When you subtract, you are getting a remainder 3. Now bring down the next period or the next pair from the dividend and place it over here and make it the new dividend. Now whatever quotient you get over here, double that. So 2 square is 4. We got down the 4 over here. Okay. 2 square 4. Now leave some space over here to enter a digit. Now what digit you will enter? Whatever digit you enter over here, the same digit has to be entered here above the period for the next digit of the square root. Also keeping in mind that this as a number, this is the new divisor. The new divisor multiplied with the new quotient should be giving you this dividend. Alright. So how do we decide what number I will put over here? You check the last digit here in the new dividend. It is 9. So you have to find out what number multiplied to itself brings a 9 in the units place. Either numbers having 3's in the units place when multiplied, they bring a 9 in the units place in the product, or numbers having 7 in the units place when multiplied will bring a 9 in the units place. So 43, we could have tried with 43 into 3, 9 and 129, not enough. Next I tried with 47 into 7. Here you might give trials to check the number. So this was 329. So I placed 7 and got the answer. Square root of 729 is 27. Alright. Going to the next sum. 7056. So here we have 4 digits in the square. So you can see that the number of periods here are 2. Now 70. Which number is closer to 70? Which perfect square? 64. Because 70 is not a perfect square, but a perfect square that is closer to 70 is 64. So 8 8s are 64. Minus 6 is the remainder. Now bring down the next pair. Okay. Now what I said? Double of this. 8 square is 16. Now place something over here and something over here. Same digit. So that we get a 656. Alright. Now which digits placed in the units place when multiplied with the same digit gives a 6 over here? Either 4s, because 4 4s are 16. So either 4s you can place, or you can place 6s over here. Okay. So either a 4 or a 6. Either of these two you can place. So let's see if I put 164 into 4. See, easily we got in the first chance. 164 into 4. So here we will put, so 164 into 4 is 656. Remainder is 0. So square root of 7056 is 84. So this is less time taking than prime factorization method. Okay. So this will be of much more help to you. Okay. So the square root of 7056 is 84. Now the third question is there already on the board. Take 15 seconds and finish it up quickly. Quickly. 5, 5, 6, 9, 6. Find the square root. Quickly. Come on. Okay, let's check those who have done, they are right or wrong. So we can see once we start putting them in the pairs and bars over each pair, this is one period, another period, this is a single digit. Okay, so this, for this, which is a perfect square, that is less than 5, that is 4. So 2 2s are 4. Remainder 1. Bring down the pair, 156. Now 2 square is 4. Now we'll check for a number which when placed over here, also multiplied here with the also put over here and multiplied, we get a number either equal to 156 or close to 156. So what number we shall place over there? That is, let us check. So 43 if I place. Now see, 6 means your first thing that will be coming in your mind is putting 4 and 4. So 16, 176. Going beyond this. So go for a number lesser than this. 3, 3. 129. Okay. We have no other option but to take this. So 3, 3. 129. So this is 7, 27. Now 27 means now bring down the next pair. Okay. Now for the next pair, now you will square up this 23. You will square up 23. Now don't square 9, only 3 and bring a 9. No. The new quotient is 23. Whatever is the new quotient has to be multiplied. So 23 means 46. Double of 23 is 46. Now what number should be brought down over here so that we get a 6? See, these are perfect squares. So naturally we know that this will, the last dividend will give you a 0. So either you can try 464 into 4 or 466 into 6. These two will be giving you a 6 in the units place. So once you try with 4, let's see. 4 4s are 16. Carry 1. 2. 1756. No. It's very much small. So 6. 3. See. 466 into 6 is giving you 2796. So 6 over here. 6 over here. So 2796. So square root of 55696 is equal to 236. Alright. So for those who got the answer before I started the solution, you can put a star for yourself and tap your shoulders. And for those who could not get, please go through and make sure the further sums that you do on your own, you get the answers of each of them. Alright. So we got the square root of 55696 as 236. So I hope you are now very much clear with the process of finding square root using division method. I would refer everyone to go practice this method nicely because this is a less time taking process and also less chances of getting error, because prime factorization, I've seen most of the time children making mistakes while they do the division. So this will take less time and also this is a very interesting method as well. Alright, but the choice is always in your hands, whichever you feel like. But if in the question you are asked a particular method, then you have to follow the question and go for that particular method. If nothing is mentioned in the paper or in the question, then you can use the method that is you are comfortable with. But if any method is mentioned in the question, then you have to only go by that particular method. Even if your answer is correct, you might be having some penalty for not using the method that you have been asked for. Alright, so I hope this method is quite clear and also the previous method. Hope you will go through more of sums and practice more sums based on this and also come up with your doubts if you have any. The comment section is always open for you to post your doubts and your queries. And also, as I always say, if you really like the classes that I take up, please like the channel, comment your problems, your doubts, and also don't forget to subscribe the channel and share the channel. I will be very happy to come up with more of these topics that will be suiting your interest. See you very soon in the next video. Till then, bye.